A mathematical model is a function that describes the behavior of a certain phenomenon. So let's take a look at this example. We're trying to construct a certain kind of box, and the box's dimension should meet these criteria, that its width should be the same as 3 times its depth, and its height should be 5 times its depth. And can we construct a function that represents the volume of the box as a function of its dimensions? Well, one attempt is to say this, that the volume of a box like this would be the product of its width and its depth and its height. So we could write a function for the volume as a function of 3 variables, depth times width times height. But this is not useful for 2 reasons. One, we have so many variables, it's going to be difficult to analyze with the techniques of algebra. 2, it doesn't really take into account the extra information we know, that the width should be 3 times the depth and that the height should be 5 times the depth. We would be better if we could write the volume as a function of just a single variable. And let's take a look at our information again and see if we can decide how to do that. It seems that the other 2 dimensions can be expressed themselves as functions of just depth alone. So if we take our single variable to just be d, the depth of the box in inches, then to say that the width is 3 times its depth and its height is 5 times its depth is the same as saying that the width is equal to 3 times d and the height is equal to 5 times d. So we're able to express w and h in terms of d only. Now our picture is much simpler. We have all 3 dimensions in the picture, but all can be expressed using the variable d only. And that means that instead of a function of 3 variables, I have a function just of 1 variable d. And the new volume is the dimension d times 3d, because that was my width, and times 5d, because now this is my expression for the height. And multiplying that all together, I have that the volume of this particular box under these constraints is 15d cubed. This is a much better function to analyze. So can we use this model? We now have a connection between the depth of the box and the volume of the box. So what is the volume of the box if the depth is 1.5 inches? Well, this is the same as asking what is the function b evaluated when d is 1.5? And we can plug 1.5 into our function and multiply everything out and find that the volume when the depth is 1.5 inches, the volume of the box is just over 50 cubic inches. I should also be able to answer a question like this, that if I know the volume is some given amount, can I figure out what the depth must have been to give me that volume? Well, I have the equation that volume is equal to 15 times the depth cubed. And if I know that the volume is supposed to be 90 cubic inches, that's the left side of this equation. Volume is on the left side of this equation. So I've substituted in 90 for my volume, and I know that that's equal to 15d cubed. And now I can try to solve this for d. I can divide both sides by 15. I could take the cube root of both sides. And if I put that into a calculator, I get something about 1.82 inches for the depth. And it means that if I choose the depth to be around 1.82 inches, then I'm going to have a volume of about 90 cubic inches for the box.